Welcome back, guys. I promised a video explaining the differences between the three types of hydraulic fluids that you typically find in construction settings. So we have your regular, your basic hydraulic oils, your AW32s, 46s, 68s, so on and so forth. We've got your tractor hydraulic fluids, and we've got your 10-weight engine oils that are often specified by OEMs to use in the hydraulic components. So let's dig into these three. I've organized them into different columns here, and I will put this on my website so that you have this that you can reference if you ever think of a question while you're out in the field. So a regular or a basic hydraulic oil, and remember, this is for construction. Hydraulic oils are for so many different types of industries and applications, but then they're formulated for construction settings. They're taking into a lot of different considerations that construction is going to bring about. So a regular or a basic hydraulic oil is going to be your least expensive option. Now, let me put a little side note off that all lubricants can usually come in different levels of synthetics, so they'll come in mineral or synthetic versions. They'll get really specific into different needs of different applications. But in this setting, we are just talking about your basic AW 32, 46, or 68. Mainly 46 is what you'll find, at least up here in the Midwest in construction. So least expensive option, comes in mineral and synthetic versions. Your main additive chemistry is going to look different than an engine oil. It's going to have your anti-wear agents, which we've talked about before, which is your zinc and your phosphorus, unless, of course, you are using a zinc-free version, which a lot of job sites that have environmental needs will call for zinc-free products. But in this case, basic hydraulic oil, zinc and phosphorus. Hydraulic oils are going to have good demulsibility, meaning that they are going to separate from water, which is why you're able to walk out to your piece of equipment on the job site in the morning before you start it up, open up that reservoir and let the water drain out, because the hydraulic oil is designed to do that. Hydraulic oil is going to reduce the incidence of stick slip. You're going to have anti-foaming properties in there. Really, its main goal, aside from lubricating in the construction setting, is going to be to transfer power. You're going to have little to no friction modifiers in there. And your best bet to use this year-round is going to be in warm climates. And I say that because we go back to that demulsibility. If you use an engine oil, and we'll get into this, engine oils are going to be better at emulsion. So they're going to keep water in suspension. They're not going to separate, meaning there's going to be a less chance that that water can freeze in a cold environment. In a warm climate, you never really have to worry about freezing, so it's okay for that water to separate and sit on the bottom of the reservoir because it's not going to freeze down there and cause damage. So that's why I say that here. Construction customers, I say, should also ask for that you can get outdoor specific hydraulic oils. So of course I have to talk about Shell. Shell's got one that has got a better viscosity index, so that it holds up better over larger temperature swings, which I always offer up to my customers who are in construction, because we're in the Midwest, we're outside, temperatures fluctuate quite a bit. Moving on to tractor hydraulic fluid. This is typically the equivalent to a 10W30 when you're talking viscosity. It's going to be your most expensive option when it's branded, I should say. It's going to also come in mineral and synthetic versions. This is really was designed and developed to use in hydrostatic applications. So that's where you have a piece of equipment where the hydraulic and the transmission systems run on the same fluid and share the same reservoir. This contains friction modifying properties, usually in the form of materials that we don't normally talk about on my Instagram. Usually I talk about friction modifiers and grease in the form of solids like moly and graphite, but in this case it's going to be a different property that you're not going to see on a oil sample. But they have these friction modifiers in there because of the hydrostatic application. So you have a lot more gear systems in that transmission, and that is going to require friction modifiers. These modifiers attach to metal surfaces to help separate and reduce friction. Tractor hydraulic fluids are going to have a lower pour point. They're going to be more protective of gears and wet brakes. There's little to no detergency in there. And then they're best for large temperature fluctuations. So again, like here in the Midwest. And then we'll hop over to 10-weight engine oils. I think CAT is probably the main proponent of doing this. It's the middle of the road on price point. It also comes in different mineral or synthetic versions. There's usually high levels of zinc and phosphorus in this because it's technically an engine oil. Engines require high levels of anti-wear agents. There's going to be also high detergency in either calcium, barium, or magnesium. Typically calcium is what's going to show up the most. No friction modifiers here either. This is not good for water separation. So emulsion in an engine oil is going to really keep that water in suspension. It's not going to separate, and it's going to prevent it from freezing. Why would we want to use an engine oil? It's ease to the customer. It prevents possible cross-contamination with engine products. So when your maintenance crew in the shop's got a million different products on hand that they have to use, if an engine oil is called in all of the components, it really eliminates that risk for cross-contamination. And then, as I said, the freeze protectant. So that's kind of the really quick, basic rundown of these 3 different products, why you would use them, why certain OEMs call for them, what the applications they're good for, so on and so forth. Now, I want to get into the chemistry a little bit more, so I'm going to pull up this little chart that I put together, and I took this information from technical data sheets from some Shell products and from some unbranded products. I want to show you what they look like. So when you have a technical data sheet, and I'm going to do a separate video on this on how to read one for hydraulic oils. When you look at that, there's usually a chart on there that shows a bunch of different chemistry type terms. And I'm going to kind of briefly explain why that's going to show me the difference in these products. So if we first look over here, we've got your basic hydraulic oil. Then we've got the tractor hydraulic fluid, the 10-weight. Shell's got a 10-weight hybrid product that's actually designed for construction applications when 10-weight engine oil is called for. A regular 10-weight engine oil is here, and then I've also put up an unbranded tractor hydraulic fluid here. So when someone asks me if they want to switch between a product, so hey, this machine calls for this AW46, all I have on hand is either 10-weight or maybe a tractor hydraulic fluid, can I use it? Now, everything is dependent upon the application, the environment, warranties, so on and so forth. But really, yes, you can most of the time cross between all these when you take some things into consideration. So we have your viscosity grades kind of mapped out here, and it's important to pull up your viscosity chart. And you're lucky that I have one here on my website off to the right hand side. Oil viscosity chart. Alright, so this guy here. So when we are crossing between products, ISO VG, this is going to be your viscosity grade for hydraulic oils or R&O oils or circulating oils, but in this case we're talking about hydraulic oils. Then over here for your crankcase, this is going to be your engine oils. So when we look at a data sheet, it's going to say viscosity at 40 degrees Celsius. So we go back to this chart, we find the 40 degrees Celsius column, we go down to whatever it says. This one says 46. Hydraulic oils are going to be pretty dead on with what they're listed as. So if we come down to your 46 at 40 degrees C, that should cross over to 46 for your ISO grade. But then if we keep going and we want to see what a hydraulic oil is equivalent to for the viscosity on an engine oil, it's going to be right in this area, so somewhere in the 20 weight range. Now, keeping that in mind, they can also run this test at 100 degrees C. So that's this column here. It's going to get you the same results, really. So if we look across this chart to figure out how these products differentiate, you want to look at the viscosity grade. That's going to be your most important factor to consider. So here we've got your AW46, which is a viscosity grade of 46. Your tractor hydraulic fluids are typically equivalent to a multi-grade engine oil in like a 10W30. Or if you want to see how it matches up to your hydraulic oil, it's going to be between an AW46 and an AW68, right here at the 60 mark. So a little bit heavier than your AW46. Then if we keep going, we've got your 10-weight hybrid, which is going to be a lot like your regular 10-weight, so we'll kind of keep these two together. These guys are going to be closer to between an AW32 and an AW46, so a little bit on the lighter side. Same thing over here. And then when we keep going, we're back over to an unbranded tractor hydraulic fluid, so it's going to be a lot like the Shell branded ones, so closer to or between an AW46 and an AW68, so a little heavier. Now, that's all fine and dandy, but if you are in a very temperature or you have a very specific temperature need, you want to be careful, because if you put in something that's a little too heavy on a colder day, that's going to not run quite as efficiently through the machine, and it could cause some overheating. Same thing with something that is lighter than what you might need. If it is a very hot day, it's going to run a little bit thinner than what you might need. Now, again, all application specific, but lubricants in this instance are generally very forgiving, and so if we're talking about general construction, heavy equipment, you are pretty darn safe using any one of these products when it comes to the viscosity. They are all pretty close. My rule of thumb that I tell my construction customers is you are safe going above or below 1 viscosity grade. Like when we're talking about your hydraulic oils, if a machine calls for an AW46, you will be pretty safe using a AW68 or an AW32, one up or one down. If it calls for an AW32, I would not necessarily recommend you go all the way up to an AW68. But again, this is all dependent upon the application. So now if we kind of look down here and show you some of the additive chemistry. Now, I had some samples of regular hydraulic oil and some samples of 10-weight engine oil that I used for this, and these are just generalizations where they're typically going to fall. I don't have any on hand for tractor hydraulic fluid or the 10-weight hybrid, so I hope to get some added to this, and then I will upload this to my website as well. But if we're talking about a regular hydraulic oil, anti-wear agents, zinc and phosphorus, are going to fall within these ranges. Your detergent, which is your calcium, is going to be on the lighter side. It's going to fall in 40 to 70 parts per million. These are also detergents, but calcium is your most common one for these applications. And then there's going to be no friction modifiers in this product. So that's your regular hydraulic oil. Trace amounts of calcium, trace amounts of detergents in your tractor hydraulic fluid, as well as these guys are going to have friction modifiers again. So we talked about that hydrostatic application that requires friction modifiers. You won't see that on a sample result, but they are in there. 10-weight engine oil. Engine oils are very high in their anti-wear properties as well as their detergency. So 2,500 parts per million, that's probably on the higher side, but that's pretty typical for your engine oil. We've got a little bit of magnesium, a little bit of boron, no friction modifiers in these guys either. So it just kind of helps you when you're looking at a sample result. Let's say somebody did not label the product, they forgot to put what they used on the sample, or they mislabeled it. You're going to be able to tell what it is by the additive chemistry. Really, in construction, when trying to convert between one of these products, you really just want to focus on your viscosity. Always, of course, consult your manual and what the OEM is requiring, but then we can move on to our viscosity grade and figure out where to go from there. I hope this helps. I really suggest looking at a data sheet, collecting this information, lining them all up side by side so you can see the difference between the products that you're considering, and then using your viscosity chart to figure out where they all equate to one another. Let me know if you have any questions. I'm happy to help. Please don't hesitate to reach out. Thanks, guys.